All right, we're back at it. We got about 2 more weeks left of new material, and then you guys got that like third and a half week or so to get makeup work done. So it'll be 2 more weeks of new material this week and next week, and then you'll have some makeup time to wrap up everything and all that. So we're going to move on to radicals. We're just going to get a very quick overview of radical functions. We're going to just simplify some radicals this week. Next week we'll look at some basic radical equations, and that'll wrap us up for new material for the year. So we've already done some of these pieces. I'm just going to throw in variables this week. So just very quick recap here. We know perfect squares. We have square root of 25 is 5, square root of 49 is 7, square root of 16 is 4. So we go ahead and just keep all that in mind. Keep your perfect squares in mind. It's going to be helpful. So first thing we need to do is simplify. This is the stuff that we've done. Square root of 20, it's not a perfect square, so we go ahead, we split it up. Find the biggest factor of 20, that's a perfect square. The biggest factor of 20, that's a perfect square, is 4. Square root of 4 times square root of 5, square root of 4 is 2, and then square root of 5 is just square root of 5. Either of those two answers fine. You don't need that multiplication symbol, so I have both there for you. I'd prefer the second one. Next example, just a couple others. Square root of 27, same deal. Biggest factor of 27, that is a perfect square. It's 9. Square root of 9 times square root of 3. We get 3, radical 3 is your answer. Next, 48. This one's a tougher one just because there are multiple factors that have, or of 48 that are perfect squares, 4 and 16 to be exact. 16 is the biggest factor of 48 that's a perfect square. That's the one you need to use. That gets you the answer the quickest way. So we have square root of 16 times square root of 3. Square root of 16 is 4. Square root of 3 is just square root of 3. If you don't pick square root of 4 or 16, you got a lot more work, as you can see. I'm not going to go over that, but that's just, you can still get the same answer. It's just a lot more work involved. That's all. I would focus on that top portion there. All right. Last one to make note of before we get into some newer stuff. We have 5 radical 24. 24 is not a perfect square, but we do have a number out front. That's where it's different on this one. All that's different in this, so I still find the biggest factor of 24, that's a perfect square, and that's 4. Square root of 4 times square root of 6. Square root of 4 is 2. Everything is being multiplied, so 5 times 2, when it comes out, ends up being 10. And then it's 10 radical 6. So whatever's out front gets multiplied by whatever needs or whatever comes out of the radical there. So in this case, it's 10 radical 6. All right. That was review, hopefully. New stuff, potentially. Variables. We know the square root of x squared is x. At least I hope we do. Technically, I don't have time to go over all the properties for exponents. But technically what this is square root of x squared is the same thing as saying square root of, x to the 2 over 2 power. And 2 divided by 2 is just 1. So all of these, it's the same thing. Square root of 8, we can say it's square root of 8 divided by 2 because it's the square root. So 8 divided by 2 is 4. 26 divided by 2 is 13. Notice all of these, we're just cutting the variable in half, or the exponent in half. That's all a square root is. So, notice here, with square roots and even exponents, only even, you just divide the exponent in half. That's it. Simple as that. Cut it in half. But that's only half the numbers. That's the even numbers. What about the odd numbers? So what about like the square root of x cubed? We think about what we did for, like, say, the square root of 8. Split up the radical. So you're thinking to yourself with these variables, what's the biggest even number that's less than 3? Well, it's 2. So break the radical up. X squared times square root of x. Square root of x squared is just x. Square root of x is just x. It stays inside. So what about some others? Square root of x to the 9th. What's the biggest even number that's less than 9? It's 8. So you split it up, square root of x to the 8th times square root of x. So you split you cut the even one in half, so it's x to the fourth. The solo x stays inside. Notice all of these have just one x left over. I make note of that. With square roots, an odd number exponent, you will always be left with an x inside the radical. Let me make that a little bit more specific. Exponents. Alright, you're always going to be left with one x on the inside. That's it. Alright, clean that up. Now, let's combine everything on these last couple. I got 6 more to go. We have square root of 25, x to the fourth, y to the eighth. First thing you do is break all the pieces apart. Square root of 25, square root of x to the fourth, square root of y to the eighth. Take care of each piece individually. Square root of 25 is just 5. Square root of x to the fourth, it's an even exponent, so cut it in half. X squared. Y to the eighth, even exponent, cut it in half. Y to the fourth. There's your answer. Next one. Square root of 9, x to the 12th, y squared, all square rooted. Take care of each piece individually. It's nice and easy when everything's a perfect square. Not much work involved. Let's step it up just a little bit. Now we have some pieces that are perfect squares, some that are not. Break the 3 pieces apart. Take care of each piece individually. Square root of 64 is 8. We eventually get there. I just rewrote it twice. You can do what you want. You can call it 8 in this step. I don't care. Square root of x to the 10th, that's an even number, so we just cut it in half. Now the y to the 15th is what we need to take care of. We split it up into y to the 14th and y. Y to the 14th just gets cut in half. Square root of y, just square root of y. Circle that up, there's your answer. Similar problem here. Get rid of that. Now, let me just kind of make note of something here. We split it up, square root of 12, square root of x to the 7th, and y to the 10th. We have a lot of pieces that need taken care of in this one. 12, 4, and 3. Notice color-coded all the way through. I want to focus on this step here. We have everything taken care of. Everything's square rooted and all that. Now I just need to rearrange my answer. Anything without a radical goes out front. Just kick it out front. 2, x cubed, y to the 5th, all goes out front. Anything with a radical gets put at the end underneath one radical. And that's it. Alright, that's the only thing I wanted to kind of point out on this one. Last 2 here. This is just 2 more examples. Same thing, it's just everything needs to be split up. 48, we already saw that earlier. 16 and 3, so 4 and radical 3. 17, you go x to the 16th and x. Y to the 31st is y to the 30th, y. Take care of each piece individually. Anything without a radical goes out front. Anything with a radical, tuck it in at the end. Last example here. Same exact type of stuff. So I'm not even going to kind of talk through it. You guys got your notes and my notes there, color-coded. Hopefully that all helps out. Alright, we got a worksheet simplifying radicals this week, and then next week we'll look at very quick stuff of radical equations, and that'll be it for new materials. 2 more weeks, 2 more weekly surveys, 2 more worksheets, and that's a wrap for the 2019-2020 school year. If you guys have questions this week, hit me up. Otherwise, hope you guys have a good week. Alright guys, see ya.